Hello, I am Muttaya Shanmugam. I am going to teach you the technique of modeling, simulating and applying control to any model in Python environment. The model is represented as a set of differential algebraic equations. Why we learn through this method in the first place? Control system simulation using Python. Having strong basics is very important in controls theory, and this way of modeling and simulating your own systems in Python helps you to learn the basic concepts intuitively and build a strong foundation to the subject. As you develop a model from scratch, you will be able to understand the model equations of motion, interaction of dynamic elements in the system, influence and sensitivity of key parameters, and other minute details. This method can be adapted to any model which can be represented as differential algebraic equations. Since Python is an open source software which is free and has many inbuilt functions, you don't need to buy any expensive software to simulate simple systems. Dynamic parameters, which refers to any user-defined constants and variables in the system, can be changed, and their influence can be seen within seconds by simulating the updated model again. What do you learn in this course? 4 key things. You will learn how to create a model in Python for a system represented as differential algebraic equations. Since there is no control in the system model, it can be called as an open loop model. You will also learn the part of deriving equations of motion for the exercises in this course. You will learn how to create a simulation setup to simulate your system in Python. You apply a step input to the system and simulate it for few seconds. You will learn how to apply control to the open loop system. In our examples, we have used PID control, but it's not limited only to PID. You can apply any type of control strategy to this simulation. You will learn how to change model parameters like spring stiffness, mass and other constants, and simulation parameters like start time, end time, step size, and rerun the simulation and analyze the results. This concept of system modeling and simulation can be applied, expanded, and further analyzed with different simulation parameters and control techniques. All the system equation derivations and Python scripts used throughout this course is made available for you as resources. Additionally, a template with comments is also provided, which you can use to build your own models, simulate them, and apply controls. What is expected from the participants before taking this course? So you need to know the basics of Python, like how to run a code, how functions work, and the basics of controls theory, like what is open and closed loop system, what is system equations, or what are equations of motion, transfer functions, etc. The basics of mechanical system modeling and simulation. The conversion of system equations into differential algebraic equations. To summarize, the primary goal of this course is to model 3 mechanical systems and simulate them using Python environment as an open loop system. Later, apply control and convert them into closed loop system. By regulating one input parameter, we try to achieve the desired output parameter or output measured value. I'm excited to share the information that will make you look at the control system simulation in a better perspective. Let's get started.